Hi, everyone. We are going to go ahead and get started. We may still have a few people logging on. My name is Susan Habistack. I am with the Lake County Stormwater Management Department here in Lake County, Ohio, Northern Ohio. We are very happy that all of you guys are here to join us today. This has been a great salt week for us so far. Just some reminders, go ahead and mute yourself. And for questions throughout the presentation, if you can type those into the chat, and we will answer those at the end of the presentation. In case you haven't been on for the other webinars earlier this week, Winter Salt Awareness Week is a collaboration of governmental and non-governmental organizations across the US and Canada. And winter salt use damages infrastructure and threatens the health of lake streams and drinking water, which many of us already know. Our goal is to raise awareness around salt pollution, and promote some of the best practices in using salt to control snow and ice. So Neopipe is a group here in Northern Ohio. A work group is a regional consortium of soil and water conservation districts, conservation organizations, and other government agencies committing to improve water quality in Northeast Ohio. So we have been collaborating since 2002 to develop and provide regional resources to increase public awareness of stormwater issues and opportunities to protect our shared waters. So we are primarily here in the Lake Erie watershed for Neopipe. We do have some that are in the Ohio River watershed, but primarily we are Lake Erie watershed. So we definitely all work together, and we are excited to be a part of Salt Week. So today we are happy to have our local Ohio speakers to give us their perspective from Ohio. We have Tim McLelland and Richard Stuck. And Tim, for the past 24 years, has worked at the Groundwater Consortium, managing their source water protection program and experience. Tim has a BS in environmental science, geology concentration, and earth science minor from Morehead State University in Kentucky. He is a member of the American Waterworks Association, National Groundwater Association, the Groundwater Foundation, and the Ohio Environment Association. Rich Stuck manages the source water protection programs for Greater Cincinnati Waterworks, 2 drinking water treatment plants, the Richard Miller Treatment Plant, which draws water from the Ohio River, and the Charles M. Bolton Groundwater Plant in Fairfield, Ohio. Mr. Stuck has over 30 years of experience in hydrogeology, aquifer characterization, and environmental geology, and source water protection. He holds a BS in geology from Stockton University and an MS in geology and geochemistry from Miami University. He also holds an Ohio Class II water supply certification and is a licensed professional geologist in multiple states. So today we are going to be talking about managing the increasing risks of groundwater salinization in a sensitive drinking water protection area. So with that, I think we will hand it over to you, Tim.
All right, thank you very much. I'll go ahead and share my screen here. Let's see. Right, can everyone see my screen? Okay, so I'm here with Rich Stuck from Greater Cincinnati Waterworks. We'll be talking about salinization in sensitive drinking water protection area and the increasing risk we've seen over the years, and a little bit about what we are doing about it. So get started here with some background on what source water protection is. So basically, source water protection is surface water, streams, rivers, or lakes. But in our case here in Southwest Ohio, groundwater and aquifers that serve as drinking water, referred to as source water. So source water provides water for drinking water, public drinking water supplies, and private wells throughout our region in this area. The consortium consists of 7 large and small public and private groundwater suppliers and users here in Southwest Ohio, just north of Cincinnati, just to give you some reference on our geographic area. The members of the consortium include a private company called Southwest Ohio Water Company, and it's a consortium of private companies that utilize industrial groundwater in the region. We also have the city of Hamilton, which has 2 water plants. They pump around 16 million gallons of water per day, groundwater per day for their needs. Also, city of Fairfield, which is right here in this region. They pump around 6 to 8 million gallons of water per day, groundwater. Greater Cincinnati Waterworks actually has 2 facilities, one on the Ohio River and one up here in Butler County. The one here in Butler County pumps around 16 million gallons of water, groundwater per day. Southwest Regional Water District is a rural water supplier here in the region. They serve around 43,000 customers with groundwater every day. And Butler County Water and Sewer is a water customer of Greater Cincinnati Waterworks and the city of Hamilton. They distribute water to most of the eastern part of our county. And Molson Coors is the other private company that actually utilizes groundwater for all of their beer products in Trenton, Ohio. And they serve most of the Midwest with all of their products. So why form the consortium? So the decision to participate and fund the development of a joint source water protection program was based on a few of these factors. There's actually a few more, but these were some of the primary factors. Overall cost savings for all the members. Rather than just have 7 of me, they decided to hire 1 person to manage the source water protection program and basically make it one large program. The hydrogeologic complexity of the area and the close proximity of all the well fields kind of overlap one another, and I'll demonstrate that with a few slides here in a minute. And knowing the boundaries of the source water protection area, so each of the members wanted to kind of have an idea of where each other's source water protection areas were. And of course, the lack of zoning control for a few of the members. Greater Cincinnati Waterworks is actually in the Fairfield jurisdiction, and Fairfield has the zoning control. And obviously, there's some ordinances, local laws that are helpful to protect their water supply, and city of Hamilton's wells are mostly located in the city of Fairfield. Also, Southwest Regional Water District relies on Ross Township and our Butler County area to implement zoning for their well field areas. Also, St. Clair Township is another township in our region that implements zoning to support that consortium member as well. So what is a well? A lot of variability in the details, but there are 3 main types. There are dug wells, there are driven or pounded wells, and drilled wells. Basically, a well is a hole or an excavation used to extract the liquids from the subsurface, and almost all modern wells are actually drilled. So there's 4 key components to a well. There's a riser, a screen, and the screen looks like what you see in the upper right-hand corner, in the picture in the upper right-hand corner. A cap, cover, and a well head, and then a pump for that well. The wells can vary in size, in diameter, and depth. Most of the wells in our region can range anywhere from 100 feet deep to as deep as 250 feet. They range in diameter from 16 feet diameter to as far as 20 feet in diameter with some of our collector wells, but most of them are around 24 to 26-inch diameter wells in our region. As far as groundwater extraction goes, you basically have static water level, and that's the elevation of the top of the water with the pump turned off. And then you'll have drawdown, the amount of water level that drops in the well during pumping. And this drawdown happens all around the well. It's basically in a three-dimension, resulting in a cone of depression. And I'll talk a little bit more about that as I talk about what are called time of travel zones here shortly. So each day, members of the Groundwater Consortium pump on average around 62 million gallons of groundwater. These are examples of what some of the wells look like in our region: Southwest Regional Water District off to the left, City of Hamilton in the middle, and a Cincinnati Waterworks well on the right. You can't see it too well, but the well in the middle, the City of Hamilton, we call that well number 5. In the background of that well, there are several City of Fairfield wells located right behind that production well. So drinking water protection areas cross multiple jurisdictional boundaries in our region, like many other facilities all over the country. And there's over 315,000 water customers and hundreds of companies in our area that rely on groundwater as a source in this region. So these are very, very common components of source water protection for a lot of source water protection programs across the country. Delineating or identifying the source water protection areas or the most sensitive drinking water protection areas, a potential pollution source inventory where you go out and inventory facilities within those sensitive areas and basically evaluate the sensitivity of that facility over top of the aquifer, and how they're storing regulated substances and where they're storing things at that site. Management, whether you've got regulatory or non-regulatory approach. And in our case, we have both. In our particular case, with the regulatory side of things, we rely on overlay zoning in the area, and we leave that zoning control with the independent jurisdictions. They maintain the zoning control, but we support them and help them with technical expertise on that. We also administer a very comprehensive groundwater monitoring program that Greater Cincinnati Waterworks basically oversees and implements for the Groundwater Consortium on behalf of the Groundwater Consortium. And then we also do contingency planning. Each year we update our contingency plan and our support to first responders. Although we're not first responders, we do support our first responders with information gathering and basically prepare and share information with our water utilities if something's going to be a risk to their water supply. And then, of course, public education and outreach. We do quite a bit of that throughout the year. And then we also do alternate water supply planning pretty much year-round. And that's pretty much independent of one another, but we also do that jointly. So why source water protection? It's one of the first critical barriers against drinking water contamination and other risks to drinking water supplies. Protecting source water from contamination can reduce treatment costs and does reduce treatment costs. Pollution prevention is more cost effective. It's estimated to be 40 times more costly to clean up contamination than prevent it. Here in Hamilton, Ohio, Chemdyne was one of the first Superfund sites in Ohio. It's taken over 40 years of cleanup at that site. They haven't removed all the contamination, but they've done a good job at removing most of the volatile organic compounds at this site. This facility happened in the late 1970s, early 80s, where they started to do groundwater pump and treat at this site and clean up. In the lower right-hand corner of this picture that you can see a question mark on the side of that drum. That's not how we label drums these days. These pictures are from the Ohio EPA. We were fortunate enough to have these pictures taken by them to demonstrate how we don't encourage facilities in our region to store over top of impervious surfaces. We basically like facilities to store drums like this indoors if they can, label them all, or just not store this type of material at all on site. Several Southwest Ohio communities are dealing with impacts of expensive groundwater cleanups. And in our region, we have a sole source aquifer. The Great Miami Berry Valley Aquifer is the only source of drinking water for most of the residents and businesses in our region. And there's a mandate from Ohio EPA, if any water utility wants to install a new well, they have to have a program in place to protect source water for their existing wells and any future wells that they want to develop in the region. Here's a snapshot of what our Great Miami Berry Valley Aquifer looks like. Basically sand and gravel deposits. It's designated as a sole source aquifer in 1988. It's a sustainable single yield well of basically 2,800 gallons per minute in southern Butler County, largely unconfined, a coupled system with surface water. And we also I want to demonstrate here with this picture in this map that we have what are called time of travel zones, the time it takes for groundwater to move underground towards our drinking water production wells. It's basically a footprint of areas contributing to the water supply over the next 1, 5, and 10 years. So these areas are what we consider to be our most sensitive areas over the aquifer. These contribution zones are called time of travel zones. And these are the same time of travel zones depicted over an aerial photograph, just to kind of give you an idea. Up in the upper right-hand corner, there's an airport there, an airport landing strip. These time of travel zones can go for miles away from some of these wells. You can see the 1-year time of travel zone here for well number 11 for Hamilton, the 5-year time of travel zone for that particular well, and the 10-year time of travel zone extending all the way out here. So it'll take 10 years for water to move underground all the way to this drinking water production well. And here is a cluster of wells. This is called the Muskoff well field for city of Hamilton. There's about 5 production wells right in this area. And at any one time, 2 or 3 of these production wells might be running, and that's why that area looks fairly large. This is the 1-year time of travel zone, the 5-year time of travel zone for that area, and the 10-year time of travel zone. As far as our potential pollution source inventory, there's over 400 businesses within our contaminant source database. The risk depends on the location, manner of storage, the quantity of material, and the geology in that area. The inventory is updated every 2 years. And so where you see the orange and purple dots on this map are where there's potential contaminant sources or leaking underground storage tanks or existing underground storage tanks. So it's pretty complex here on the map. You can see that we've got quite a bit of activity going on here. So a lot of examples of potential pollution sources in our region. These are some of them: landfills, illegal dump sites, salvage yards, chemical and petroleum storage in above ground and underground storage tanks, pesticide fertilizer use at golf courses, city parks, recreational areas, residential properties, over application of road salt on parking lots, driveways, improper road salt storage, gas stations leaking USTs, auto repair shops, gravel pits, crude oil pipelines that cross through our area. So a lot of examples of potential pollution sources, and that's just the tip of the iceberg. So here are some examples of some pictures I've taken at some of our inventories that we've done in the past. Some poor housekeeping, above ground storage tanks. Now, they did have the right idea to have secondary containment, but of course, you know, when they go to fill up these pieces of machinery that they're using, they have over spillage, and over time that's going to get down into our aquifer. We don't have a confining layer in our area that's going to protect our aquifer from this contamination on the surface of the ground. Eventually it's going to make it down into our aquifer. So these types of things, we like to have them get cleaned up. We do have many leaking underground storage tanks, and a lot of times these volatile organic compounds will float on the surface of the water table. But we do have these problems in our area around where old gas stations are. There's some gas stations that still have old orphan tanks in the ground, still working with the state and federal agencies to get them yanked. We do have illegal dump sites that pop up here and there, and oftentimes it ends up causing people to think that this is a great place to take hazardous materials or hazardous waste, and that has happened in the past. So a lot of challenges in our drinking water industry, drinking water demand and locations for additional wells. We have a lot of development patterns going on, which ends up causing a hindering of development of water supplies, gravel mining operations are in our region, new regulations by state and federal agencies, and proposed new well regulations tied to source water protection programs, and the requirement of utilities to comply with these new regulations in order to maintain high water quality at a really cheap price. We also have emerging contaminants and security that we have to deal with in our industry. And as part of management plan to minimize the possible contamination from potential pollution sources, we use three primary approaches. We assist communities that have adopted these source water protection ordinances with technical expertise. We register and inventory facilities that request it, and we assist businesses with getting into compliance with these local ordinances. They're around 30 pages long for each of the jurisdictions, and we're fortunate enough to have many of these jurisdictions adopt pretty much the same exact language, so it's not confusing if a business has the same business in a separate jurisdiction. So they could have the same exact business in two different jurisdictions. They're gonna be dealing with the same regulations. So a little overview of our adopted local ordinances. Basically, it's divided into 6 major parts: the establishment of source water protection areas. We have identified regulated substances. We have some general provisions, above ground storage tank provisions, UST provisions, and miscellaneous provisions for activities and land uses not addressed in the above ground or underground sections. So the location of each of the facilities in the 1, 5, and 10-year time of travel zones matters. This is an overlay zone. All the pre-existing zoning conditions continue to apply. The manner of regulated substance storage, indoor and outdoor, matters, and the quantity of regulated substance stored on site, 55-gallon or 1,000-gallon threshold, depending on the time of travel zone. So it's 55-gallon in the 1-year time of travel zone, 1,000-gallon in the 1,000-gallon threshold in the 10-year time of travel zone. So there are prohibited types of activities in our source water protection area. The establishment of new activities or land uses in each of our time of travel zones include, but aren't limited to, and I only listed a couple of these, but junkyards, commercial sanitary solid waste, C&D landfills, auto repair shops, trucking or bus terminals, storage of regulated substances that exceed threshold limits. Oftentimes, I consider these to be kind of common sense, especially when it comes to the sensitive areas. So the applicability of the ordinances regarding road salt storage include, for any new facility, all road salt stored at new facilities in the 1-year time of travel zone and 5-year must be stored under a covered shelter on an impervious surface capable of catching, diverting, and controlling stormwater runoff. And this requirement does not apply to prepackaged for consumer use material. They also have to register their facility in the 1-year time of travel zone if they're storing road salt outdoors in quantities exceeding 1,000 pounds. And it must be registered in accordance with a certain section within our ordinance, which includes quite a bit of information. I didn't want to list it here, but it's basically contact information and probably about 4 pages worth of material they have to fill out. So these are the registration requirements and I just kind of sum this up. There's basically 4 forms they have to fill out: a general facility data form, an above ground inventory form, an underground storage tank form, and a spill control plan form. We interview the business owner or the manager of the facility, then walk the site. Inventory of the facility will be based on the time of travel zone, quantity thresholds established by ordinance for the jurisdiction. There's no fees, licensing fees, or operation certificates required. Overall, it's been a great experience working with the business community. Everyone wants clean water. Everyone wants clean drinking water. So at this time, I'll turn it over to Rich Stuck with Greater Cincinnati Waterworks to talk a little bit about our groundwater monitoring.
Okay, thanks, Tim, and hi, everyone. Appreciate being here today. As Tim mentioned, my name is Rich Stuck. I'm the Source Water Protection Manager for Greater Cincinnati Waterworks. You'll hear me refer to it as GCWW as we go. And as part of that role, since we are members of the Groundwater Consortium, we oversee the monitoring program for the larger source water protection program that includes all the consortium members. So the purpose of this slide is sort of a standard disclaimer type thing. I'm going to show some data here shortly, and I just wanted to make sure everybody understands that this is from, or these data that we show you are all from monitoring wells. So we have an extensive monitoring well network that I'm going to talk about in just a second. And none of the data that we show is actually from our well fields themselves. So the good news is that currently a lot of the effects that we're seeing from salinization are away from the immediate areas of the well fields, and all of the consortium members currently meet all the state and federal drinking water criteria. So with that out of the way, let's go ahead and jump into it. As I said, we have a fairly robust monitoring program. Includes a large section of central Butler County through the aquifer area. And in many ways, it's one of the more technical and important parts of the Groundwater Consortium, because these monitoring wells serve as early warning indicators for changes in water quality, so that we can do and implement some sort of management strategies before any of these issues actually show up as a drinking water issue. So this is a picture on the right-hand side of the slide, an example of some of our monitoring well locations. I'm going to show you the anatomy of a monitoring well just to get everybody on the same page in just a second. But here's some details. So our groundwater monitoring program, we currently monitor 39 monitoring wells, collect samples from those twice a year, typically in April and October. And then in some areas where we have some issues that we're monitoring a little bit closer, we will collect more frequently on a quarterly basis. We also, because Tim mentioned fairly in passing, but I'm going to show you in a second too, we have a what's considered a coupled system between the surface water and groundwater. The water in the aquifer actually is in communication with the water in the Great Miami River. And so we also include surface water monitoring in our monitoring program as well. And we're not the only organization out there looking. Ohio Department of Natural Resources, an organization called Miami Conservancy District, U.S. Geological Survey, and Ohio EPA all have monitoring programs either for water quality or water quantity as well. And so through this network, we actually do have access to several hundred monitoring wells if we ever needed to expand our monitoring network. This is just a quick cross-section of what a monitoring well looks like. These are different than production wells. They're typically much smaller, typically 2 to 4 inches, sometimes 6 inches in diameter. Monitoring well really is nothing but a pipe stuck in the ground with a screen at the end that allows water to come in. And we're able to collect samples through that pipe and get a sample of the aquifer in each of those locations. They are also fairly prominent, at least the way that we construct them with the type of covers that we have on them. So we use these actually as educational tools as well, and we typically have educational signage near some of our more exposed well locations. Just a quick note for for the aquifer. This is what the aquifer looks like in cross section. Tim showed you the overview map, which the aquifer, if you looked at it, looked like a thin ribbon going from areas north of Dayton all the way down to the Ohio River. Is what's called a glacial outwash deposit. So this is an ancestral stream valley that's been filled in with sand and gravel as part of glacial outwash. And what this picture shows is a couple of things. One is that we often refer to our aquifer and cross section as being a bit of a bathtub. So there's in our area, the bedrock is limestone and shale, and it's got limestone on the sides and limestone on the bottom, and then the water gets trapped in the sand and gravel deposits above that. Typically, aquifer depths in our area, in our part of the aquifer, are roughly about 250 feet. And there's very, very little clay. So we don't have any clay cap. We don't really have extensive clay layers in southern Butler County. And so, so the system is completely unconfined from a hydrogeologic standpoint. And it also means that there are very few barriers, as Tim mentioned, to contamination migrating through the unsaturated soils and ultimately getting into the saturated zone, the saturated portion of the aquifer. This is our monitoring network in plan view overview. In this particular map, the monitoring well network that I'm going to be talking about are the red and white circles. And just for reference, the consortium members' production wells are shown as the blue and white symbols. We have a total of 39 monitoring wells in 8 surface water locations. Our monitoring wells, actually several of our locations are in what we call well clusters, where we'll have 1 or 2 wells, or I'm sorry, 2 or 3 wells installed to various depths within the water, within the aquifer. So we're monitoring not just a single location depth-wise at that particular location. And one of the reasons that we do that is that, as you'll see, there are differences in what happens in the shallow portions of the aquifer versus what happens deep in the aquifer. And our area of interest for most of the well fields actually is the deepest part of the aquifer. So let's get back to the sodium and chloride question. We've been monitoring groundwater quality in our network since 1999-ish for most locations. And so monitoring sodium and chloride has been part of that monitoring program since the beginning. And what we see here are called box and whisker, or just sometimes box plots. And this is all of our data since the monitoring program began. And each box represents a roughly 5-year period. And if you're not familiar with these types of plots, roughly 50% of the results are contained within each individual box. And then the upper percentiles are above the box, and then the lowest quartile is actually below, and then the anomalies plot above that. The thing to really notice, though, is the line through the center of the box. That's the median concentration for both sodium and chloride. And you can see, especially for sodium, there's a consistent increase in sodium through our entire data set through the period listed. Chloride went up early in our record and then sort of leveled off, but it's kind of a misnomer because you can see certainly in that period from 2015 to 2019, our chloride numbers were very spread out. But I'm going to get into some individual graphs here that show that a little bit better. So as we did our groundwater sampling and started to compile the results and do the trend analysis, a number of things started to show. And this is what we would consider sort of a typical pattern for a lot of our sampling locations. There are 3 wells listed here. This happens to be a 3-well cluster. And the light blue is the most shallow monitoring wells. The golden color is more of the middle part of the aquifer. And the darker blue dots and trend is the deepest part of the aquifer. And as time went on, from the beginning of our monitoring period, the chloride numbers went up starting in roughly 2012-ish, significantly in this particular location. Kind of peaked before 2020, and then in this particular location started to actually decline. Same thing with the sodium. We see a number of increases there. And so we started looking, we've done this type of trend analysis throughout our monitoring program, and we found sometimes that the trends were fairly subtle. This happens to be a location in a residential neighborhood in a park. And over time, there has definitely been an increase, a doubling in the chloride concentration since roughly 2006, and about a similar scale of increase in sodium, but it's not a jump. It's just a long-term gradual increase year to year. The change is not dramatic, but over time it certainly has been a very definitive increase. That's not the case in all of our locations. Some of our locations, actually, the rate of increase was much higher. We've noticed this too. The chloride number tends to be a little bit noisier than the sodium number, but you can see in this particular instance, there was a significant jump in concentrations in both sodium and chloride at this location pretty substantially and pretty quickly. We do have some areas that are away from, residential areas, away from industrial areas, just kind of out in the middle of some fields where we actually don't see that same type of increase. So it's pretty much been flatline across since 1999. And some of the trends that we have seen is that the shallow groundwater, as you might expect in certain areas, is being impacted far more than the deepest part of the aquifer. So if you're not familiar with groundwater movement, groundwater does flow, it does move in the aquifer. In our area, it could move 1 to 5 feet per day, and that's actually moving fairly quick on a groundwater standpoint. But we got interested in these trends and thinking, okay, if this is happening in the shallow groundwater, is it going to affect the deep water? Where is it coming from? What does this mean? Is this a natural phenomenon? Is this a man-made phenomenon? You know, we had a few questions to answer. And so these are some of the implications of finding that answer. Obviously, from a drinking water standpoint, neither sodium nor chloride have primary drinking water standards, but there are some health guidances out there, and chloride has something called a secondary maximum contaminant level, which is based on an aesthetic quality of the water. And so, especially with sodium, we're cognizant of the fact that there are health implications related to higher sodium numbers. Just from the aesthetics, at a certain point, we're concerned about a salty taste. Increasing dissolved solids also comes with some of this type of pollution. And then, not to be forgotten, the potential of additional corrosion for drinking water infrastructure. So that all kind of layered into our analysis and our hope to try to find out where this was coming from, and to the end where we could potentially develop some mitigation strategies. So back around 2014 is when we really started ramping up. 2015 was when we really started to ramp up our interest in this as we saw these trends were continuing. Came across a USGS study that characterized potential salt sources of salinity based on the chloride concentration versus the chloride to bromide ratio. So we began adding to our monitoring network, adding the bromide ion into our analyses as well. We actually added iodide as well, but that's not part of our this presentation. And since that time, we were able to use those fields that USGS developed and look to see where this might be coming from. And the majority of our data plotted in this area on that graph that says mixed sources. So the very top curves on that particular graph are straight halite. That would be straight salt. Down towards the bottom, you get into more septic and sewage related area. So in the middle, we get into this mixed area, a mixed source, which is kind of appropriate for us when you really look at our area, bigger than just the local communities. We are in an agricultural area. It kind of makes sense that there may be some influence, not just from road salt, which kind of some of our data does definitely plot up into that halite dominated portion, but also peeking down into the area where fertilizer might be an issue as well. So kind of makes sense. This slide I put in here just to reiterate what one of our well fields looks like from an aerial perspective, why we were looking both at groundwater and why we were also looking at source water. You can see just how close some of the well fields are to the Great Miami River. So the salinity conditions within the Great Miami River, even though it's a surface water, became a part of the question as well. There are some other groups that are doing excellent work for surface water in the Great Miami River. I've shown two here. One is the one on the left is the data set from Heidelberg University. They've been monitoring chloride in the Great Miami and plotting this, making this plot available that shows chloride versus discharge. And the Miami Conservancy District has taken their data as well as some of the Heidelberg data and flow normalized the average, the mean concentration of chloride in the Great Miami River. And honestly, based on the MCD data, there's not been a huge increase in chloride. There's a bit of a bump, but a lot of the flow normalized calculations for the Great Miami made it look like the chloride was, it was elevated, but not increasing. So couldn't it really explain some of the trends that we were seeing in the groundwater? So we had to look elsewhere. So we went back to the potential contaminant source inventory that Tim mentioned as part of our source water protection program, and to try to develop a working model of where the sodium and chloride might be coming from. Our general assumption was that even though sodium and chloride are both naturally occurring at low levels in our aquifer, the increasing salinization that we were observing was predominantly anthropogenic. We kind of, after analyzing the potentials for where this could be coming from, saw that there was a high likelihood that road salt application and coupled with the widespread use of dry wells for stormwater management was a leading contender, and fertilizer and other agricultural activities certainly were part of that puzzle as well. We do also see, as I mentioned, the wastewater treatment plant discharges are part of the Great Miami River, and we do have the induced infiltration. So it's not saying that the Great Miami River is not a player in this, but it is not the only player. So I mentioned the stormwater management, and there's a community here, highly residential, where the topography doesn't allow for great stormwater management. And so they have a number of dry wells that they use as part of their stormwater management system. Those dry wells, there's a cross section of one of the construction types. So basically the stormwater drains directly down through those dry wells into the aquifer. And that kind of definitely fits the model where we're seeing increases in chloride and sodium in the shallow part of the aquifer. So there have been some success stories in this. This is one. As part of our monitoring program and subsequent development of management strategies, there was a large parking lot that we identified as a particular source of sodium and chloride. It definitely localized, but it was significant. And working with the owner of that parking lot, there are a number of changes that were made, including the rate of salt application and the construction of some new stormwater management structures on their property. And we have definitely been seeing a decrease in both the sodium and chloride concentrations in the groundwater in wells adjacent to that parking lot. So that is one area where it looks like some of the monitoring clued us into an issue where we could actually take some actions and solve a problem. So it's good to see that that's working. And as I mentioned, the shallow groundwater typically is the most susceptible to this contamination. Not always. There are places where we actually do see higher concentrations in the deeper part of the aquifer. But in this particular case, this is an ongoing issue where a community has a small but poorly managed salt storage facility. And our monitoring wells just happen to be, by coincidence, happen to be on the adjacent property. And even though the deep water there is almost unaffected, the shallow water certainly is affected by some of their salt handling practices. So that's an area that we have ongoing communication with that particular community. Hopefully we get that solved. I'm going to go ahead and pass this back over to Tim. He's going to talk about some other initiatives that we have.
Start to wrap our webinar up here. Want to talk about some of the other next steps we've been taking. After evaluating some of these data trends that Rich talked about, we decided to take a few other actions. We gave a couple different presentations on our source water protection program overall to a couple of our local public works departments to share this data and kind of understand some of their challenges, including their staffing and overtime, weather forecasts that they have. We usually get a lot of rain and ice in our region when they are predicting snow, and of course they're preparing their salt trucks for a large snow event, and they end up getting a bunch of rain after they've already applied brine out on the roads, and of course sometimes they'll put down salt ahead of time, and it's completely out of their control, and we obviously understand that. We've also set up a lot of meetings with various engineering departments throughout our region about road salt storage and best management practices to kind of understand some of their challenges and what some of their perspectives are. And really, this has really been helpful for us to understand where they're coming from and kind of open up communication lines and dialogue between us and our concerns about sensitive drinking water protection areas, let them know about these sensitive drinking water protection areas, and just basically a reminder when they are applying road salt out there to give them that extra information. Another thing that we recently applied for was a very small mini grant from the Ohio Environmental Protection Agency. In 2023, we were awarded this grant from the Ohio Environmental Education Fund to raise awareness about the importance of protecting local drinking water sources through best management practices of road salt usage. The OEEF was created by the General Assembly in 1990 to enhance Ohio citizens' awareness and understanding of environmental issues. It's administered by the Director of EPA. They usually have around $700,000 annually to administer these grants to various groups around the state to support environmental education efforts around the state. So as part of that $5,000 mini grant, we have developed a road. It's basically a bike path sign, very similar to the one on the right. It's not complete yet. It's in the making right now, but we're hoping to install this new educational sign along the Great Miami River bike path, explaining basically what salinization is and how it affects our drinking water, ways to reduce salt contamination starting with individual homes. It will actually include some of those graphs that Rich showed, and it'll also talk about ways you can help us protect the sensitive aquifer underground where you're riding your bike right through this area over the winter time. And we also, I think you heard earlier in the week, if you've been paying attention to the webinars this week, about the Isaac Walton League, and in our neighborhood around this area and by what's called Waterworks Park in Fairfield, we've developed packages for chloride testing kits through the Salt Watch program run by the Isaac Walton League of America. We've also developed what are called salt cups that the consortium had made, mimicking those created and distributed by, and I'm giving a shout out to the city of Greater Sunbury, Ontario, that measure the necessary amount of salt for any given area for homes, and just to be more conscientious users of, and to reduce overuse of road salt, and already existing educational materials that the Salt Watch program has through the Isaac Walton League. And this is an example of what our cup looks like. Basically, this cup can provide enough road salt for a driveway, essentially, and a sidewalk for residents at their home. There's just a nice little message there about application of road salt at your home And then, of course, on the other side of the cup is information where you can get more information about the Groundwater Consortium, but also the Salt Watch program. This is the neighborhood that we're targeting. On the left-hand side, where you see the baseball diamonds, is essentially where the well fields are located. The drinking water well fields are located. That neighborhood is where we targeted a couple hundred homes to participate in this. And we had 25 people actually respond. There's more coming. This is what the postcard looked like that we sent out to everyone, and it's got a QR code that you could scan to take you directly to our sign up process to sign up for the Salt Watch kit that we will basically hand deliver to each of the homes. This is what the other side of that postcard looks like. I'm not going to read all the detail on this, but it was interesting because we had so many people reach out to us, and they're talking to some of their neighbors about getting involved in this. So we're pretty excited that we had some people respond to this. We also have information again from the Isaac Walton League that includes brochures about proper application of road salt at your home and what the implications can be if you over apply road salt in your neighborhood. And so these brochures and this additional information is added into this little kit that we're sending out to all these homeowners. And here's another example of additional information that's going out. So we're not trying to start up something new. We're basically taking existing information and putting it out there and utilizing the Isaac Walton League as a partner in all of this to administer this grant. So additional educational opportunities we're going to be using. Another outreach event that we'll be doing is at our Children's Water Festival that we do each year in the fall. We plan to have a presentation on road salt application to fourth grade age kids. We'll encourage them to obviously shovel snow at their house and any of their neighbors putting down road salt, make a little extra money on the side, demonstrate the damage road salt can do to our environment as a visual to the kids, give kids test strips to compare tap water and water with salt in it to see the difference, and then give them that knowledge they can take home and share with their family. This Children's Water Festival is an annual hands-on day event about water quality, quantity, conservation, pollution, water uses, pollution prevention. A variety of different presentations go on this one day. 1,000 kids show up at a local college here in our region at Miami University for this all-day event. We have multiple presentations by various organizations on water resources that are hands-on. The kids are directly involved. We don't bore them with a PowerPoint presentation. All the kids are actually actively involved in every one of these presentations. They're 30 minutes long, back to back. So it's a great opportunity to give these kids a chance to learn about water resources and how water can be polluted and maybe some solutions to pollution. But we hope to talk with them about road salt application and how they can help at home by using that shovel and shoveling that snow rather than throwing down a bunch of road salt on their driveways and sidewalks. And that's one way they can help us because it starts at home. So that'll probably wrap up our webinar here, and we'll be happy to take any questions at this time.
All right, thank you. Thank you for the great presentation. We did get a couple questions here. We have some people saying they did get their kits they're going to be using. Okay, here's our first question. Do water plants remove or reduce chloride? If yes, what level in parts per million and what method?
Take that.
Yeah, none of the consortium members' plants would remove. So none of the plants that are in our network would remove chloride. That's a specialized treatment technique that that we don't have in any of our consortium members' treatment plants.
Okay. All right, and our next question here, are you able to inspect the different businesses in the area to make sure they are not contaminating the groundwater? Is this voluntary for the businesses, or does the consortium have jurisdiction to go on private properties?
So as far as the ordinances go, the facilities are required to register their facilities if they meet those quantity thresholds that I talked about. So if they store 55 gallons or more, and then there's a amount of pounds requirement, like a threshold that if they meet that threshold, if it's meet that threshold or it's higher, then they're required to register their facility. So the zoning departments have that authority, and the zoning inspectors are the ones that maintain that authority, but they can authorize me to go out on site with them or in lieu of them if they choose. But we don't act as a regulatory agency. Most of the time when I go out to facilities, it's oftentimes to help those facilities get into compliance with these local adopted ordinances. And most of the time it's usually a pretty friendly encounter because I won't say that they're usually confused, but they can sometimes be overwhelmed with what's required and what is not, just because it can be overwhelming if it's the first time you've seen it. But it's required every 2 years, and we send out reminders every 2 years that they have to do this. And it's only for those sensitive drinking water protection areas. It's not the entire city of Fairfield or the entire city of Hamilton. It's just within those jurisdiction, those time of travel zones that I talked about, the 1, 5, and 10 year. And each of those time of travel zones has certain restrictions that apply. So.
Thanks.
Yep.
Okay, our next question. What type of stormwater practice was implemented at the large parking lot? Or do you have a favorite practice for intercepting and reducing impact from salty runoff?
Okay. So as far as that large parking lot, I don't recall offhand. Do you remember offhand?
Yeah, I can. So one of the biggest things that they did there, probably the most impactful thing that they did there was to actually decrease the amount of salt that they were putting down to begin with. It was an extreme example, in all honesty, and what percentage of the decrease that represented, I can't really guess. So part of what they did was they also put in some dry ponds that I'm not entirely certain what the engineering thought was behind there. I don't know if it was simply diversion away from the recharge area near the wells, or if there were, other things that they implemented as part of that. We weren't really part of that discussion, but in all honesty, I think that the lion's share of the decrease came from just their approach to salt management in that parking lot. It was, as I said, it was an extreme example of over salting.
Yeah, and the good thing about it too was they recognized it. They came to the consortium. They came back to the consortium and talked with us about, what were some things that we could do. They saw the data, recognized the data, and made those changes on their own voluntarily. So.
Okay, we've got one last question here. How does a drought affect your results, and is algae an issue?
Typically, when we look at the effect of drought, there's a little bit of a delay when it comes to groundwater. So the effects are not always immediately obvious. If you looked at the graphs for the Great Miami River, that's where you're going to see the most effect most easily. And generally speaking, if we go back to that graph, you'll see that at higher flows, you get dilution, and the chloride number goes down. And if you look towards the left of that graph, you're seeing that the discharge is low. The chloride concentration is consistently higher. So the more prolonged that's going to be in terms of drought, the more likelihood that we're going to see those higher numbers getting into the aquifer. But otherwise, I don't know that we have enough coverage near the river with our monitoring well network to really hammer home a conclusion. As far as algae goes, the Great Miami River is actually pretty free flowing, even at low stage. We've not had a harmful algal bloom, knock on wood, that we know of on the Great Miami, have we? And this was 2024 was a drought year, and even though the water quality or the clarity was there, and I assume the nutrients are there, we did not actually see an algal bloom in any of our areas that we monitor on the Great Miami this year. I assume that's the type of algae they were asking about.
We did have one more question come through. Are road salt appliers tracking their annual use?
We believe they are. So neither Tim nor I are really in a great position to answer that, because we just advise the communities that we serve. I believe that they are. Yeah, I know that they track the amount of usage, but I can't really say what the data say.
Yeah, the two public works departments I've talked to do quite a bit of tracking, from what I understand. I don't have any of that data in front of me. They haven't shared it, but it's not that they're not willing to share it. But yes, I'm aware that they do track that information. So.
Okay, I know for the phase 2 stormwater communities that we work with here in Lake County, it's required to be reported on an annual basis for the Ohio EPA annual report, how much salt was used.
Yeah.
So at least I know it's a requirement for some communities.
Yeah. Yeah, I'm pretty confident. I know they track it. I don't know what their reporting requirements are down here off the top of my head.
Yeah. Okay, I think that is all of the questions that we had. We thank you guys very much for being with us today. The contact information for Tim and Rich, as you can see, is up here on the screen for any further questions. And we hope everybody joins us tomorrow for the roundtable discussion. Thank you, everyone.
Thank you.